Imagine a world where applications are not confined to a single machine. Picture a network of interconnected computers, each contributing its resources to solve complex problems collaboratively. This is the realm of distributed computing, and java.rmi is your passport to this exciting domain. RMI, or Remote Method Invocation, is a powerful technology that allows Java programs to communicate and share resources across a network. RMI empowers developers to create distributed systems where multiple computers work together as a unified whole. It's like having a team of specialized experts, each excelling in a particular task, collaborating seamlessly to achieve a common goal. RMI provides the communication framework, allowing these experts, represented by remote objects, to interact and exchange information effortlessly. RMI's strength lies in its ability to extend the object-oriented paradigm to the distributed world. Just as objects within a single program interact through method calls, RMI allows objects residing on different machines to communicate using the same familiar mechanism. This seamless integration simplifies distributed application development, making it as intuitive as working with local objects. At its core, RMI is all about invoking methods on objects that reside on different machines. It's like making a phone call, where you dial a number to connect with someone remotely. In RMI, the phone number is a reference to a remote object, and the conversation is the method invocation and its result. To understand RMI, consider an analogy with a real-world scenario. Imagine you want to order food from your favorite restaurant. You call the restaurant, place your order, and wait for the food to be delivered. In RMI terms, you are the client. The restaurant is the server hosting the remote object. Ordering food is the remote method invocation, and the delivered food is the result. RMI handles all the complexities of remote communication, making it transparent to the developer. It takes care of marshalling arguments, transmitting data over the network, invoking the method on the remote object, and unmarshalling the result back to the client. This abstraction simplifies distributed programming, allowing developers to focus on the application logic rather than the intricacies of network communication. Just like a phone call requires a common language for effective communication, RMI relies on a well-defined interface to ensure seamless interaction between the client and the server. This interface specifies the methods that can be invoked remotely, acting as a contract between the two parties. RMI's architecture is like a well-coordinated orchestra, with each component playing a crucial role in orchestrating the distributed communication symphony. The key players in this orchestra are the RMI client, the RMI server, the RMI registry, and the network infrastructure connecting them. The RMI client is the initiator of the communication, requesting services from the remote object hosted on the server. It's like the conductor of the orchestra, directing the flow of the music. The client obtains a reference to the remote object from the RMI registry, the orchestra's program guide, which acts as a directory service. The RMI server is the host of the remote object, providing the services requested by the client. It's like the musicians in the orchestra, playing their instruments according to the conductor's instructions. The server creates and registers the remote object with the RMI registry, making it discoverable by clients. The RMI registry acts as a matchmaker, connecting clients with the appropriate remote objects. It's like the concert hall, where the orchestra and the audience come together. The registry maintains a table of remote objects, each identified by a unique name, allowing clients to look up and obtain references to the desired services. The network infrastructure, the stage on which the orchestra performs, provides the communication channels for data exchange between the client and the server. It's like the air that carries the music to the audience, enabling the distributed components to interact seamlessly. In the world of RMI, remote interfaces act as the blueprints for communication, defining the methods that can be invoked remotely. They establish a clear contract between the client and the server, ensuring that both parties understand the services being offered and consumed. Imagine a vending machine. It has a clear interface, buttons for selecting items, and a slot for inserting coins. This interface defines the contract between the user and the machine. Similarly, a remote interface specifies the methods that a client can invoke on a remote object, acting as the contract for distributed interactions. A remote interface extends the interface, marking it as a special type of interface specifically designed for remote method invocation. This interface serves as a flag, indicating that the methods declared within it can be accessed from other JVMs across the network. Each method declared in a remote interface must throw a checked exception that signals potential communication errors. This exception handling mechanism ensures that clients are aware of potential network issues and can handle them gracefully. Remote objects are the stars of the RMI show, the entities that provide services to clients across the network. They are like actors on a stage, performing actions based on the director's instructions. In RMI, the director is the client, and the instructions are the remote method invocations. A remote object is an instance of a class that implements a remote interface. It's like an actor who has learned a specific role defined by the script. The remote interface specifies the methods that the object can perform, while the object itself provides the implementation for these methods. To make a remote object accessible to clients, it needs to be registered with the RMI registry. This is like an actor getting listed in a casting directory, making them discoverable by potential employers. The registry acts as a directory service, allowing clients to look up and obtain references to remote objects based on their unique names. Once a client obtains a reference to a remote object, it can interact with it as if it were a local object. RMI handles all the complexities of remote communication, making the interaction seamless and transparent. It's like watching a play, where the audience is unaware of the behind-the-scenes complexities of stage production. The RMI registry plays a pivotal role in the RMI ecosystem, acting as a central hub that connects clients with remote objects. It's like a matchmaking service, pairing individuals with compatible partners based on their preferences. In RMI, the clients are seeking specific services, and the registry helps them find the remote objects that provide those services. The registry maintains a table of remote objects, each identified by a unique name. This is like a dating profile, providing essential information about the individual seeking a match. Clients can query the registry using these names to locate the desired remote objects. When a server creates a remote object, it registers it with the registry, associating it with a unique name. This is like creating a dating profile, making oneself available for potential matches. The registry acts as a directory, allowing clients to browse and select the services they need. Clients can obtain a reference to a remote object from the registry using its name. This is like getting introduced to a potential partner through the matchmaking service. Once the reference is obtained, the client can interact with the remote object, invoking its methods and receiving results. RMI's communication process is like an intricate dance between the client and the server, with each step carefully choreographed to ensure seamless interaction. The dance floor is the network infrastructure, and the music is the flow of data between the two parties. When a client invokes a method on a remote object, RMI steps in to handle the communication complexities. It's like a dance instructor guiding the steps, ensuring that both partners move in harmony. RMI uses a process called marshalling to prepare the method arguments for transmission over the network. Marshalling is like packing a suitcase for a trip, carefully selecting and arranging the necessary items. RMI converts the method arguments into a serialized form that can be transmitted over the network. Once the suitcase is packed, it's time to embark on the journey. The serialized data travels across the network, reaching the server hosting the remote object. It's like arriving at the destination, ready to unpack and settle in. The server receives the data and performs the reverse process, unmarshalling the arguments back into their original form. With the arguments ready, the server invokes the requested method on the remote object. It's like the dance performance, where the partners execute the steps they've learned. The remote object processes the request and generates a result, which is then marshaled and sent back to the client, completing the dance cycle. RMI offers numerous advantages for building distributed systems, empowering developers to create robust, scalable, and efficient applications that leverage the power of interconnected computers. It's like having a team of specialists working together, each contributing their expertise to achieve a common goal. One of RMI's key strengths is its ability to enhance scalability. By distributing tasks across multiple machines, RMI allows applications to handle increased workloads without compromising performance. It's like expanding a factory, adding more production lines to meet growing demand. RMI also promotes fault tolerance, making applications more resilient to failures. If one machine in the distributed system goes down, others can continue operating, ensuring uninterrupted service. It's like having backup generators, ensuring continuous power supply even during outages. Furthermore, RMI fosters code reusability, allowing developers to leverage existing components and services across the network. This modularity simplifies development and reduces redundancy, promoting efficient code management. It's like using prefabricated building blocks to construct complex structures, saving time and effort. RMI's object-oriented nature simplifies distributed programming, making it as intuitive as working with local objects. Developers can leverage familiar concepts like inheritance, polymorphism, and encapsulation to create elegant and maintainable distributed systems. It's like using a common language to communicate effectively across different teams, ensuring seamless collaboration. RMI's versatility and power have made it a popular choice for a wide range of real-world applications, demonstrating its practical value in diverse domains. It's like a Swiss Army knife, offering a multitude of tools for tackling various challenges. In the financial industry, RMI is used to build distributed trading systems that handle vast amounts of data and execute transactions with lightning speed. It's like a high-frequency trading platform processing millions of orders per second, capitalizing on fleeting market opportunities. Online gaming platforms leverage RMI to create immersive multiplayer experiences, connecting players from around the world in real-time virtual environments. It's like a massive online role-playing game where thousands of players interact seamlessly, embarking on epic quests and forging alliances. Enterprise software solutions utilize RMI to build distributed architectures that enhance scalability, fault tolerance, and collaboration across geographically dispersed teams. It's like a global supply chain management system, tracking goods and services as they move from suppliers to manufacturers to distributors, ensuring smooth operations. These are just a few examples of how RMI is being used to solve real-world problems, demonstrating its practical value and versatility in diverse domains. Its ability to connect distributed components seamlessly, combined with its object-oriented nature, makes it a powerful tool for building robust and efficient applications. RMI has played a pivotal role in shaping the landscape of distributed computing, leaving a lasting legacy that continues to influence modern architectures. It's like a classic novel, inspiring generations of readers with its timeless themes and compelling characters. While newer technologies like web services and RESTful APIs have emerged as alternatives for distributed communication, RMI's core principles remain relevant. Its focus on object-oriented design, its ability to handle complex data structures, and its support for synchronous communication continue to hold value in specific use cases. RMI's future lies in its ability to adapt and integrate with emerging technologies. It's like a seasoned actor, evolving their craft to remain relevant in the ever-changing world of entertainment. By embracing new paradigms like cloud computing and microservices, RMI can continue to play a role in shaping the future of distributed systems. As technology evolves, RMI's legacy will continue to inspire and guide developers in building robust, scalable, and efficient distributed applications. Its core principles of object-oriented design, remote method invocation, and distributed communication will remain valuable tools in the ever-expanding toolbox of software development.